Hi everyone. In today's session, I'll be explaining about NoSQL using MongoDB. That is, whenever you are using MongoDB, we will be introduced with the concept of NoSQL, which is a very new technology which is being used by many of the companies, and many of the companies are migrating their databases from SQL to NoSQL. First of all, we will be looking after the differences between what is the major differences between SQL and also NoSQL. If you look after NoSQL, it can be termed as not only SQL database, and also it provides a mechanism for storage and retrieval of the data which is not in a tabular form. That is, in earlier days, we used to have data in a tabular form which is only stored in the context of a text. But after the introduction of social media, the types of data that are being incoming to the companies and also the type of data that is being generated by the users, it has been changed a lot. So we do not require any sort of traditional database, but we need a NoSQL which will be accepting any type of data from the users. So if you look after the differences between SQL and also NoSQL, in SQL we will be using relational database management system, which also we term it as RDBMS. And in NoSQL, we can call it as a non-relational. That is, the data will not be stored in the format of a table. And here in SQL, if you look after, the databases are fixed, or also they'll be following a standard schema. That is, once you declare the structure of a table, the structure of the table has to be followed, and the data should also be inserted according to the structure of the table that has been created using the create command. But in NoSQL, it will be having a dynamic schema. That is, there will be no structure, and each entry into the database can consist of any number of fields. So that is, we can consider it as another sort of difference among them. And here in SQL, it is designed for complex queries. That is, we can say that we can use these nested queries, or else you can go on with some complex queries in order to retrieve the data. But coming to NoSQL, it cannot handle some sort of complex queries, and it is a bit difficult to retrieve the data in NoSQL. And in SQL, it is vertically scalable. That is, you can store the database in a single centralized system, and you can increase its resources in order to increase the computational capacity of the database. That is, you can add the RAMs, or else you can increase the storage capabilities, or else you can increase the processors, so that the data retrieval can be done in a very less period of time. Coming to NoSQL, it is horizontally scalable. That is, what you can do is that you can increase the number of systems in order to make the computation fast. That is, instead of having a single centralized system as in SQL, in NoSQL you can have some 3 to 5 systems where the database will be distributed among all those particular systems. So that is why we call it as a horizontally scalable system. And in SQL, we follow ACID properties, that is, which we call them as atomicity, consistency, isolation, and durability. And coming to NoSQL, we'll be following the properties of base, which we can term them as basically available, and also we can say that it is a soft state, and also we can say that it is eventually consistent. So that is the properties that we'll be following in NoSQL. If you look after the properties in SQL, that is in the relational database, we'll be following 4 different properties, which we call them as ACID properties. That is atomicity, consistency, isolation, and durability. If you look after each of these properties, in atomicity, what we say is that either the transaction, whatever the thing that you had started, it should get completed, or else it should not start at all. That is, the transaction should not get interrupted, and it should not be stopped in the middle. That is what we call it as atomicity. Next, we will be talking about consistency. Consistency is nothing but we'll be saying that the data before the transaction and after the transaction, they have to be the same. That is, we call it as the data is consistent. Say for example, if you take an ATM example, you had you had gone to an ATM machine and you tried to draw some amount from your ATM. Say for example, initially your account is having some 1,000 rupees, and after you had withdrawn some 500 rupees, the total amount that you will be having with you is 1,000 rupees. That is 500 in your account and 500 in your hand. So there you will be having 1,000 rupees in total. And say for example, if in the middle of the transaction the machine gets failed, and if you are not able to get the hand cash from the ATM machine, then what happens is that before the transaction you are having 1,000 rupees, and after the transaction you are only having 500 rupees. That is what we call it as inconsistent data. So what we say according to consistency is that whatever the data that is present before the transaction and after the transaction, they have to be the same. Next we talk about isolation. So isolation is nothing but when two or more transactions are happening simultaneously, one transaction should not involve, or else it should not interrupt the other transaction. That is what we call it as isolation. And next we'll be talking about durability. In durability, what we'll be saying is that whatever the data that has been updated in the database, it has to be stored permanently into the database. That is, no changes will be happening after the data has been stored into the database. That is what the ACID properties will be talking about in SQL. And if you talk about NoSQL, the base stands for basically available, soft state, and eventually consistent. If you talk about the basically available, the property whatever that is there, it refers to the fact that database system should always be available to respond to user requests. That is, even if it cannot guarantee immediate access to all the data, the database may experience brief periods of unavailability. But it should not be designed to minimize downtime and also provide quick recovery from failures. That is what we'll be saying is that whenever you are using basically available, the data should be available to the users without any sort of interruption 24 by 7. That is, whenever a user requests or else whenever a user wants to access some sort of data, the data should be available always. And also there should be a mechanism that has to be followed, that how we will be recovering whenever there is any sort of failure, that is the failure from a soft state or also failure regarding the hardware, whatever the type of failure it may be, how you will be responding and how you will be able to get back into the business after a failure. That is what we'll be talking about, the basically available. Next we'll be talking about the soft state. So in soft state, what we'll be saying is that the state of the database can change over the time even without an explicit user interface. This can happen due to the effects of background process, or else we can talk about the updates of data or any other factors may be affecting them. The database should be designed to handle this change gracefully and ensure that it does not lead to any sort of data corruption or else data loss. The best example you can take for this soft state is a YouTube platform. Say for example, you had opened your YouTube, you're watching some sort of videos, and after a particular period of time, whenever you close the YouTube and the next time you open it, you'll be getting a new list of videos. So what is happening is that whatever the new videos that are being uploaded into the database, they are being displayed to you. Whatever the changes that are being made into the database, that are being displayed to the user without any sort of human intervention. That is what we will be talking about, the soft state. Next we will be talking about eventually consistent. So eventually consistent means what we will be saying is that it is the data in the database despite the changes over time. That is, in other words, what we can say is that the database should eventually converge to a consistent state. Even it takes some time for all the data updates to propagate and be reflected in the data. So this is what we call it as we can compare it with a traditional ACID properties, that is consistency. That is, whenever you are not receiving any sort of data from the users, the data has to be consistent, and whatever the data that is there in the database, even though it is not getting any sort of data from the users, it has to be in a consistent state. And here you can see the various sort of companies which are using NoSQL nowadays. That is like Netflix, Apple, Spotify, Uber. All these particular companies are making use of NoSQL nowadays. And in this SQL, in this NoSQL, we talked about something called as basically available. That is, the data has to be available 24 by 7 to the users. So how we'll be doing that is that we'll be storing the same data among different locations all over the world. Say for example, here we had taken 4 different locations, something like Seattle and Berlin, New York, and also London. So the same amount of data on the same copies of data are stored in 4 different locations. Say for example, this particular center has stopped working because of some reason. Then what we can do is that immediately we can take the data from the other data center, and say for example this system also stops working, then we can take the data from other one. So that is how the basically available concept will be maintained in NoSQL. Now we'll be looking at the types of NoSQL. If you are using a graph database, then you will be having 2 different types of softwares that are available. That is Neo4j and also Hypergraph DB. And if it is a document oriented, we are having MongoDB and also CouchDB, which we are discussing right now. And if it is a family column family, then we are having Cassandra, which is an open source that is available in the market, and also we are having HBase. And if you look after the MongoDB, we can call it as an open source and also document oriented database. So what we do is that here, instead of storing the data in the format of rows and also columns, we'll be storing the data in the format of a JSON like documents, which is always a schema free. If you look after the example which is displayed over here, you can look after the object id and the name and the age and the interest and also the favorites. Here whatever the column names that are there, we'll be calling them as the column names of each and everything. So here if you look after the example that we had taken, you can see over here the names which are replaced in MongoDB. In RDBMS, we'll be calling it as a database, and in MongoDB also we'll be calling it as a database. In RDBMS, we'll be calling it as a table, and in MongoDB, we call it as a collection. In RDBMS, whatever the term that refers to row, it is referred as a document. And in RDBMS, we call them as columns, and in MongoDB, we call them as fields. Here in RDBMS index, in MongoDB also it is termed as an index. In RDBMS we call it as join, and in MongoDB we call it as an embedded document. In RDBMS we call it as a partition, and in MongoDB we call it as a shard. If you look after here, we are using a collection which stores the data of the employees. Say for example, so in the first document, what we had done is that we had taken the fields as name, eyes, birthplace, aliases, location, and also who is the boss. So if you look after this particular document, it is having like some 6 fields that are available. And coming to the next one, here we are having only 4 fields. And coming to the next document, here we are having only 2 fields. And here another 2 fields. And here you can notice age is a new field that has been added apart from these 3 documents. And here again we are having 4 fields. What we can say is that in SQL you will be following a particular structure. Say for example, you had defined a schema that a table will be consisting of like some 5 columns. Then each time you enter the data, you have to give the data for all the 5 columns, and each of the column name will be the same all the while. But coming to NoSQL, that is a MongoDB which we are using as a document oriented NoSQL, here if you observe, each document is consisting of a different number of fields and a different number of field names also. So And this makes MongoDB a very flexible one, because here we are not defining any sort of schema. It is not consisting of any predefined data schema. So every document will be having its own different data. So that's why we many companies are moving, or else they are migrating to MongoDB nowadays. And if you look after the features of MongoDB, you can say that it is a document oriented storage, and it consists of full index support. That is, make a note of where actually your data is. It is having replication, that is, the data will be stored in different locations, and also it is having high availability, that is the base properties which will be following. You can also be having auto sharding and also aggregation, and also you are having MongoDB Atlas, which is a cloud version that is available, and it has various APIs like JavaScript, Python, Ruby, Perl, Java, Scala, C Sharp, C++, Haskell, Erlang. In any sort of programming language you can embed this MongoDB, and also it is having a strong community, where if you are having any sort of problem, you will be able to post your doubts or else your concerns into that particular community, and whoever the experts are there, they'll be able to answer, or else they'll be able to provide a particular solution for whatever the query that you are having. So this is the brief introduction of what actually MongoDB is. And if you are having any sort of concerns, you can post your questions in the comment box. Thank you.